Okay, so the last objective is objective 4 for non-distinct items. So if things are repeat and they look the same, they're going to be on the bottom and your total's on top. So with the word statistics, we decided that there's 10 total letters, but when you look at S, how many S's are there? 3. So we'll have a 3 factorial down here, and that's for the letter S. Because they're all the same size, shape, color, so when I start scrambling them, you're not going to know the difference from them. All right, look at T. How many times does T repeat? 3. So that's for T. What about A? Just once. You could put a 1 factorial down there, guys, but 1 factorial is 1. I don't worry about it. I just look at the ones that repeat. We already did the T. What about the I? Twice. And that's for I. And then we did the S, the T, the I. What about the C? Nope. And so then you close it off. So this is a key thing, guys. All of that's in the bottom. So when you go to type it, make sure you have parentheses around all of it, because if not, it will just do 10 factorial divided by 3 factorial, then multiply by the 3 and then the 2. So we want to, in our calculator, there's no shortcut for this one. He's kind of annoying, okay? So we're going to have to do 10 and then math, scroll over to PRB to get factorial. Divided by parenthesis 3, hit math, scroll over to PRB to get your factorial. 3, math, scroll over to PRB. I wish there was a copy and paste option, but there's not. So see that? You have the parentheses around it, and when you hit enter, you should get the right answer. So even though the letters repeat and they're non-distinct, you still have over 50,000 ways you can rearrange that. But again, I think a better example is my bookshelf. I have 10 math books on my bookshelf. 3 of them are stats books, 3 of them are college algebra, and 2 are elementary algebra. So they're non-distinct, so when I start rearranging them, you can't tell the difference between them. All right, so what is the whole point of this section? It's kind of off kilter from what we've been doing, probability, probability, probability. Well, the whole idea is now that we know how many ways things can happen, we can start putting it into action and actually help us solve probability problems. All right, so objective 5, this is like the last 2 on your homework. Last 2 on 5-5 homework. I don't know if you write notes like that. These are like the last 2 on your 5-5 homework. All right? So it says the counting techniques in this section that we just learned can be used to determine probabilities of certain events by using the classical method. All right? So say there are 8 dentists and 6 doctors from which a committee of 4 needs to be formed. Compute the probability when you go to pick those 4 people, you pick exactly 2 dentists and 2 doctors. Let's start off with, is order important? How they're chosen. Is anything special happening? No. I mean, who I'm choosing from special, but once they're chosen, they're just on this committee, right? So we're going to be using C. So we want to know the probability of 2 dentists and 2 doctors. All right? I focus on the bottom always first. I don't know why. I guess sometimes I think it's the easiest, like how many total people are you choosing from, that kind of idea. So what we're going to do is we're going to have a giant C down here. We're going to use combinations because order is not important. How I choose these dentists and doctors, whether I choose the dentist first or the doctor first, it doesn't matter. They're going on this committee, all right? So when I go to do the C, this is always for my total, right? So how many total dentists and doctors am I choosing from? 14. Do you guys agree with that? I'm choosing from 8 dentists and 6 doctors. So I'm choosing from 14 dentists and doctors. How many total am I choosing to be on this committee? 4. Okay? So if you just want to know how many ways you can choose 4 people out of 14, that's all we would do, right? But they're being more specific. They want to say, of those 4, how many are dentists or how many doctors? So up here, guys, you're going to have 2 C's multiplied, right? Because you're going to pick one and then the other. Make this first C for your dentist. Make the second one for a doctor. And just do a baby version of what we just did below, okay? But just focus just on dentist and just on doctors, okay? So how many total dentists are there to choose from? 8. And of those 8, how many am I worried about choosing to be on my committee? 2. All right, we're done with the dentist. Let's go do the same thing with the doctors. How many total doctors are there to choose from? 6. And how many am I worried about choosing to be on my committee? 2. What I want you guys to notice is that the 2 left numbers on top should always add up to the left number on the bottom, right? You had 8 dentists and 6 doctors, so you had 14 total. And then the 2 right numbers, you wanted to pick 2 dentists and 2 doctors, so you're picking 4 total. So these 2 numbers should always add up, okay? So down here, honestly, I would calculate this individually, because guess what? Part B will be, what's the probability that you pick 3 dentists, 1 doctor? Your bottom will be the same. You're still choosing 4 from 14. So throughout your homework, your denominator will be the same. It's your numerator that's going to change, okay? So what is 14 combo 4? 1001. Okay? And then up here, just do them individually and then multiply, okay? Did anybody have a chance to do 8 combo 2? 28. And then did anybody have a chance to do 6 combo 2? 15, okay? And all we're doing is using, remember you type it first, so we type 8 first, hit math, scroll over to PRB, pick the combo, and then put 2. All right, what's 28 times 15? I think you get 420 over 1001. I think most of these guys, they have you put it in a decimal, so let's just say that's approximately 0.42. On your homework, this will be part A. Part B will be 3 dentists, 1 doctor. What's the only thing going to change? These little numbers up here, because you're still choosing from 8 dentists, but now you're going to choose 3. We're still choosing from 6 doctors, but now you're going to just choose 1. These little right numbers are going to be the only things that change when you go from A, B, C, D. Okay? All right, the last one's just for fun. Okay, does anybody gamble? Okay. Sometimes it's fun, all right? So my dad lives in Vegas, and he's a person that needs to live in Vegas. He has the best luck, okay? He plays Keno all the time and wins $500 at a time on a daily basis. It blows my mind. I would say, so when are you going to share that with us? And he doesn't. But if you were playing the Powerball, how the Powerball works is that you choose 5 numbers out of 55 numbers, and then you choose 1 number out of 42, okay? If the grand prize is given out when all 6 numbers are correct, what is the chance of getting the grand prize? So order doesn't matter, so we're going to use combinations for the 5 balls, and then there's 55, so this is basically what's going to happen here, guys. We have 2 C's going on down here, okay, because we're going to pick from 55 balls first, and how many are we choosing from? Choosing 5, and then we're going to pick 1 number from 42. And I'm just going to say there's 1 winner. There's more than 1 winner, but and when it comes down to it, it's not that big of a difference in the probability. But let's just say you want the probability of you getting 1 of the winning tickets, right? So 1 out of it. If you do the denominator, let me write the denominator down real quick. So you have 1 out of, what is this? 146,104,962, okay? If you do that division in your calculator, hold on, let me count. 1, 2, 3, 4, 5, 6, 7, 8 zeros. Okay. 1, 2, 3, 4, 5, 6, 7, 8 zeros. 6, 8, 4, 4. That's your chances of winning the Powerball. Crazy, isn't it? Like, don't they say you have a better chance of getting struck by lightning twice in your lifetime or something like that? It's unreal. Does that mean don't go gamble? No, have fun. Sometimes you might hit it, okay?